A warm good afternoon, class. Today we are going to see a most important topic in metallurgy, and that too particular towards the ferrous division, right? So that is tool steel, right? Tool steels. So as the name implies that this particular steel is used as the tool mainly used for machining process, right? So here you can see this particular tool steel is mainly used for machining the materials which has less hardened than this tool steel, so that we can change the shape of a material according to our necessity or which suitable for the particular application. For example, if we have a rod, we can convert that rod into a taper turned material, taper turned shape, or you can make a square rod into a circular shape, or we can make a drill over a particular rod or a particular bar like structure. So this all particular this all made up of but a tool known as tool which is made up of tool steel. Okay, let's go deeper. So here the tool steel, apart from the other steels, this tool steel is developed in a very particular way, where the ingredients or the chemicals which is alloys are added in a controlled manner in order to develop the mechanical properties like durability, strength, corrosion resistance, temperature stability, and even though the shock resistance as well. So that when compared to the other steels which is used in the other application, this tool steel will have the higher or good mechanical properties. So that here the carbon contents ranging from 0.1 to 1.6%. So this increasing addition of the carbon will helps to improve the hardness of the or the strength of the particular tool steel. And apart from the carbon, we can see chromium, molybdenum and vanadium is also added, so that the precipitate kind of particles are formed in the particular microstructure of the tool steels in order to improve the strength of the particular tool steels, right? So here the tool steel is used from various applications. In particular, I can say it is used for blanking, die forging, forming, extrusion, plastic molding, taper turning, facing, milling, drilling, reaming, shaping, planning, etc., right? So the next one is that this tool steel is majorly classified into 5 types, and it is subclassified as well. So the first one is shock resistance tool steel. As the name implies that these are used in the machining process where a high impact is made. So for example, in a smaller way, you can say in the construction works, you can see sledgehammers are used to break the TMT rods. So at that way, you can see the nail which is used to cut the TMT rod is made up of a steel which stands the shock, as well as the sledgehammer head should be shock resistant. As the same way, this shock resistant tool steel is made in that way, such way that in order to have resistance towards impact. Second one is cold work. So it is further classified as oil hardened, air hardened and high carbon, high chromium. Means that here the high carbon, high chromium means the carbon and chromium content is added in a little higher format or in higher way, so in order to improve the mechanical properties for the particular working environment. So the second one is air hardened and oil hardened. Here the hardening happens with the oil or air, means that here the quenching process happened through oil and air in order to improve the hardness of the particular tool steel. Okay, the third one is hot work. Here it is here it is chromium based, tungsten based and molybdenum based. As like the cold work, here hot work, it is chromium, tungsten and molybdenum. Means here this chromium or the tungsten or molybdenum is added in a higher range, so that this elements will form a precipitate inside a tool steel, so that in order to improve the hardness or the strength of a particular tool steel. Okay, so the next one is high speed tool steel. We can see that here in this high speed tool steel, this name particularly is seen in many in a common colloquial term, where this Here it is tungsten molybdenum based, as like chromium which is used in the hot work. You can see here the tungsten molybdenum is added in a higher amount in order to improve the property of the particular hardened high speed tool steel. And the last one is water hardened tool steel. Okay, we'll see these types of tool steels in a more explained way in the upcoming videos. Thank you.